Why is DHA so important for brain function and cognitive health? When you're savoring a tasty meal, or when you're enjoying your favorite music, or when you're wrestling with a mentally taxing task, you are setting into motion whole cascades of neurological processes. Millions of electric signals are fired in specific areas of the brain, and millions of neurotransmitters are released in the synaptic clefts, which are the microscopic spaces that separate each two neighboring neurons. These very complex processes hinge on your neurons' ability to communicate by sending and receiving nervous signals. When this communication is smooth and undisturbed, your brain functions optimally and you enjoy optimal psychological and cognitive health. When this communication is hindered, your brain powers gets negatively affected and your mental health and performance are compromised. One of the key factors that play a key role in these processes is the fat composition of your nerve cell membranes. In other words, the communication between your neurons is only as good as the quality and consistency of fat in their membranes. Now, why is DHA so important in signal transmission between neurons? Well, in a healthy, optimally functioning brain, DHA makes up 50% of cell membrane. It's essentially concentrated in nerve endings, and that's where it is needed the most. DHA is the most flexible and fluid of all omega-3 fatty acids. It confers these unique qualities to nerve cell membranes to allow them to fulfill their function properly and make it possible for the brain to perform its miraculous deeds. Thing is, during this communication between neurons, an electric signal travels across the neuron until it reaches the extremity of its dendrites. The dendrites are the structures branching out of the neurons. Then neurotransmitters are released into the synaptic cleft to carry the signal to the neuron of destination. This neurotransmitter must then be able to dock properly on the neuron of destination. This is only possible if this neuron has a fluid, pliable membrane that allows the neurotransmitters to fit perfectly. When the cell membrane is DHA rich, it is flexible and has receptors that allow for a perfect fit for neurotransmitters. As a result, the communication between neurons is effective and optimal. However, when the nerve cell membrane is deficient in DHA, it loses its pliability and flexibility, becomes rigid, and the receptors on its surface no longer provide the perfect fit for the incoming neurotransmitters. The result is that they can't activate the signals in the neuron they belong to. Speaking of the importance of neurotransmitter receptors, Dr. Joseph Hebban, a research psychiatrist at the National Health Institute, said, "You can send out all the neurotransmitters you want, but if only 50% of the normally functioning receptors are in a state to activate the messengers, then only 58% of the messages get through." Thus, it is evident that the quality of receptors on nerve cell membranes and their DHA makeup can make or break the quality of communication between neurons. This explains why a wide range of mental and cognitive problems have been linked to DHA deficiencies, and why supplementing with DHA is increasingly suggested in treating many of these problems. If you want to learn more about the many benefits of DHA for improving focus, concentration, and memory, if you want to learn how it can protect you from age-related mental decline, and if you want to learn about its protective effects against neurodegenerative diseases such as Alzheimer's disease, vascular dementia, and Parkinson's disease, then subscribe to our channel or visit our blog dhandbrainhealth.com and watch more presentations like this one. If you love the content of this presentation, please share it with your friends and follow us on Facebook, Twitter, or your favorite social networking and bookmarking sites. Your comments, suggestions, and questions are welcome. Thank you for watching.